To find the volume of a sphere, we'll use the equation volume equals 4/3 pi r cubed. Go ahead and copy down the diagram for example 1. Since the diameter is given as 10 kilometers, that means the radius must be 5 kilometers. So to find the volume of the sphere, we'll do 4/3 pi times radius cubed. So that's 4/3 pi times 125, because 5 times 5 times 5 is 125. And so then that is 500 pi over 3. So there's our exact answer. And then we can approximate that by typing that into a calculator using the pi button. So we have 500 pi divided by 3. And that is about 523.60. And that would be, since it's volume, that's going to be in kilometers cubed. Okay, go ahead and pause your video and try number 2 and press play when you're ready to see the solution. Since the diameter of example 2 is 9 halves or 4.5, or since the diameter is 9, the radius is 4.5. So our volume is going to be 4/3 pi times 4.5 cubed. And so we can type that all in except for the pi. So 4 times 4.5 cubed divided by 3. It gives us the decimal 121.5, which you can also do anytime you get a decimal answer. You can go to math frac, and it'll put that as a reduced fraction, 243 halves. So this is 243 pi over 2. That's our exact answer. And then for all of these problems, I'd like you to write down not only the exact answer, but the decimal approximation. So that's what we now say times pi. We'll get our decimal approximation of 381.70. And this would also be in kilometers cubed. In example 3, our radius is 9.5. So volume will be 4/3 pi times 9.5 cubed. Four times 9.5 to the third power divided by 3. And then we'll go math frac. So that is 6859 over 6. So 6859 pi divided by 6 is our exact volume, and that's in cubic feet or feet cubed. And then as a decimal approximation, we'll say times pi, and that is 3591.36. Okay, again, go ahead and pause your video and try number 4. Since the radius is 8, our volume is going to be 4/3 pi times 8 cubed. 4 times 8 to the third power divided by 3. Math, frac, that is 2048 over 3. So 2048 pi over 3 cubic inches. And that is about 2144.66 inches cubed. Okay, in the next example, we have composite figures. So we have, in both of these examples, we have cylinders and spheres joined together. And so in the first example, if we just take the volume of the cylinder, so the cylinder is the volume of the cylinder is base area, so the area of that circle is, since the radius is 3, then we're going to get base area is 9 pi. The height is 10 going this direction, so we get 90 pi. And then the volume, if we take these two hemispherical ends and put them together, then that gives us, so we'd have the hemisphere for one end and the hemisphere for the other end, gives us an entire sphere. So the volume of the sphere is 4/3 pi times radius cubed, and that is 36 pi. So now when we add those, we get 126 pi cubic feet, which is about 395.84 cubic feet. Okay, example B looks like this could be a grain silo. So it's got a cylinder for the bottom and then a hemisphere for the top. So go ahead and pause your video, see if you can find the volume of this composite figure, and then press play to see the solution. Our radius is half of 16, or 8. The volume of the cylinder is base area, which would be 64 pi, times height, 25. So that is 1600 pi. And the volume of the hemisphere is 1/2 of 4/3 pi r cubed. Our radius is 8, so pi 8 cubed. So if we put in everything except for the pi, we have 0.5 times 4/3 times 8 cubed. Math frac gives us 1024 pi over 3. Okay, and so the volume of the composite figure is 1600 pi plus 1024 pi over 3, and then we can approximate that 1600 pi plus 1024 pi divided by 3. And that is about 6098.88. And that's in cubic feet. And that completes our lesson on volume of spheres.